Waiting for lesson 2.5. We're going to learn how to do some derivatives without doing definition of derivative. Okay? So some things I've said, well, yeah, the derivative of that, we'll talk about that later. Later is here. So we're going to learn a whole bunch of derivative rules today. Okay? Some of them are very basic and also tied together. And there's just flat out memorization. Okay? You've made a calculus, so I know you guys can memorize. There is just some flat out memorization that has to happen. Okay, so we are going to start with the derivative of a constant function. Now, derivative of a constant function is a horizontal line. So what would be the derivative of a horizontal line? 0, because when I say derivative, I'm saying slope of the tangent line, right? Okay, and that is the same thing. So right there, the idea here is that's supposed to be a C, not a 0. Yikes. I can't. If this line is the line f of x equals c, or if you prefer, I prefer to hear it called y equals c. If that is that line, what is the slope of that line? 0. So what is the derivative of any constant?
0.
Always 0.
So all of these are 0.
So if y is negative 4, what is y prime? 0. If s of t is 45, what is s prime of t? 0. If f prime of x is 0, if f of x is 0, what is f prime of x?
0.
0. And that's okay because f of x equals 0 is a horizontal line, yes? Okay. If y equals k pi over 2, what is y prime?
0.
0. Okay. Because k is typically a constant unless they tell you otherwise. Okay, so k is a constant. It represents a constant. Pi and 2 are numbers, yes? So that is 0. Okay, that's your first derivative rule. Single variable rule. And again, to me, when we get to power rule, I lumped both of these in with power rule. Okay? The derivative of x is 1. So right here, d dx, this is saying the derivative with respect to x of x is equal to 1. So think graphically about the line y equals x. Y equals x looks like this, yes?
Yes.
So what would be the derivative? Okay, if we're looking at that line, y equals x, the slope of the line is 1. Right? Now, do I want to do that? Yeah, I don't think I do. So, if f of x is x, f prime of x is 1. If s of t is t, then s prime of t is 1. If x of t is t, then x prime of t is 1. And all of those, it's the slope of the line, isn't it? This, if we want to talk real quick, the f of x graph is the original function, yes? I don't know if I dare. Why did I do that? What would the f prime of x graph look like? What would the derivative graph look like? What is the derivative every piece of the way?
The same.
It's 1, right? So the derivative graph looks like that. The derivative graph is the horizontal line because the derivative is always equal to 1. Okay, yes?
So I'm not going to get into it or not, but if there's 2x, would the derivative be 2?
We're not there yet.
Oh.
Okay, you ready? Hold
Yes.
on. We'll get there.
Okay.
Trust me, we'll get there. We'll know how to do all the basic derivatives today. Okay, the power rule. This is the one that we use for a lot of stuff. Okay, this is the one, all these different things fall under power rule. In my brain, the two things we just did can also fall into power rule. Okay, so if n is a rational number, then the function x to the power of n is differentiable, and the derivative of x to the n. So d dx is saying the derivative with respect to x. So the derivative with respect to x of x to the n is n times x to the n minus 1. I translate that to say, if it's x to the n, take the power of n and move it out front. Multiply it out front. Take your power that was there in and subtract 1. Okay? Seems confusing, but once you catch on, it is quick. Okay, so power rule. Move the power out front and then subtract 1 from the power. So, x squared. If y is x squared, what about y prime?
2x.
We take the 2 and move it out front, yes? And then on the x, on the power, it becomes 2 minus 1 officially, yes? But of course, we're not going to leave it like that. We're going to say that y prime is 2x.
Oh, that goes
Are we
back to
okay
what
with
you
that?
said the other day where your slope graph is like 1 unless it's like a quartic, that's going to be a cubic.
Oh.
We talked about, I mentioned it a little bit that like, yeah, if you had a quartic, the derivative graph is a cubic, or if you have a cubic, your derivative graph is a quadratic. It's always a power less. It is. Okay. Have you thought about the next one?
4x third, yeah.
Right? Because you're going to move the 4 out front, subtract 1 from the power. So yes, f prime of x is 4x to the third. Are we good?
I can still.
Now, C appears to look like a catch, but it's not. What's the square root of x?
X.
To the,
1/2. Oh, I didn't know if that was right. But here we are.
okay, so anytime you see something that's not of the form, so like this whole bottom row here, none of these in the bottom row are of the form x to some power. So we're going to have to rewrite all of this bottom row before we get started. Okay, so square root of x, we rewrite it. It's x to the 1/2. Now apply your power rule. Move the 1/2 out front and subtract 1, whoops, from your power.
1 over 2 squares of x.
Let's start with 1/2 x to the
Negative.
-1/2. Are we there? Yes?
Yes.
Now, whether you leave it like that or not depends. If we don't leave it like that, where does the negative exponent go? To the denominator. And what do we know about x to the 1/2?
Square root of x.
It's the square root, yes? So you could think of this as 1 over 2x to the 1/2, or 1 over 2 square root of x. Right? Like those are equivalent notations. Okay? Yes or no? Maybe?
Maybe. Like it'll take practice.
It will, exactly. And unfortunately, you're going to do nothing about this over the weekend, so Monday's going to be a little rough, but that's all right. It'll take practice.
Monday's always
1 over x. What do you know about 1 over x?
1. It's negative.
This is the same as writing x to the -1. Can I use my power rule now? I certainly can. So g prime of x, kind of the rough draft is move the negative 1 out front, negative 1x, subtract 1 from the power, and it's what? Negative 2. So g prime of x is negative x to the negative 2. That is more properly written as negative 1 over x squared. So what do you know about f of x being 1 over x squared?
Equals x negative 2. That's what whole 1 over x squared is.
Right. So I'm not taking any derivatives until I have x to some power. So f prime of x, move the negative 2 out front, and then subtract 1. So kind of the rough draft is negative 2 x to the negative third. More properly written, it is negative 2 over x to the third.
Yep.
And the fun one. What do you know about 1 over x to the 2/3?
The negative root of x squared.
Yeah. It's x to the negative 2/3. I want powers. I don't want to talk about roots. I don't have rules to take derivatives of square roots, cube roots, etc. I have rules to take derivatives of powers. So, y prime, move the power out front, negative 2/3, x to the, so now I'm doing negative 2/3 minus 1.
Negative 5.
And that has to be done without a calculator. Just saying. Negative 2/3 minus a whole, so minus 3/3, is negative 5/3, yes?
Yep.
Now, I will say on my answer key, I left this as negative 2 over 3x to the 5/3. I did not put it back in, I did not put it in a cube root, probably because it didn't come from a cube root. It's one of those things, if it comes from a cube root, I'm going to put it back in a cube root. Like this one, it came from a square root, so I kind of went back to a square root. This one, I didn't. Now, am I done? I'm pretty much done, aren't I? Real quick, 2 things. I don't know if I'll get them both in, but on the top part of this page, could you apply the power rule right here? Move your power out front and subtract 1 from your power. So if I move my power out front, 1 times x. If I subtract 1 from my power, it's x to the 0, which means it's just whatever my coefficient is. Okay? You're always just going down a power. And so Monday, we'll get to practice this same rule again. The only difference on this page, there's already a coefficient there. So when we move that 2 out front, what am I going to do? 2 times 3 is 6. Depending on the day, right? Depending on our math skills. So, Monday, we'll get to re-practice that rule we just learned by putting a coefficient in front. And Monday, I've got 4 pages of notes to get through that.
1 page down, 4 to go.
But, how quick did that 1 page go?
It's like, let's
Pretty easy.
Yes, wasn't it?
It went quick. So,